Welcome. My name is Dr. Eric Landrum from the Department of Psychology at Boise State University. This is a brief Jing video about how to do correlations in SPSS. Let's go ahead and get started. I've got a data file all set up here and ready to go. Just as a quick reminder, you can look at the rows are actually individuals who answered the survey, and the columns are the actual variables that were utilized in this particular data set, which was a survey. All right, and so to run a correlation, I'm going to go up to Analyze, Correlate, and I'm going to choose Bivariate. Now I've got a list. Now in this left frame are all the variables in my data set, and this right frame here are going to be the variables that are going to be correlated. And in fact, if you look at this, I can't correlate anything until I actually have at least two variables over there. I'm going to pick some ones that are going to seem familiar. I'm going to start with correlating one's age and then with their GPA. Those are good choices because they're both continuous or interval ratio scale variables, and so interpreting the correlation from that data will actually make some sense. I'm going to go ahead and click on OK. A new window is going to open up an output file. You can save this to a USB memory stick or a flash drive. Remember though that to print it, you've got to print it from a computer that actually has SPSS on it, and so it's going to be difficult to print this without that tip. All right, let's look at this table and interpret it. And so we've got the age here. We're going to follow that across. The actual correlation between age and GPA is the intersection of this row with this column. And so the Pearson correlation is a negative 0.13. Remember that correlations can range from -1 to +1 inclusive, and 0 is an appropriate option in a correlation. All right, this is a negative 0.13 correlation that we report to 2 decimal places in APA format, which means as one value goes up, the other variable tends to go down. And we can look at it both ways. As age tends to increase and people get older, GPAs tend to be lower in this data set, or the younger individuals tend to have higher GPAs. Now remember about correlations, that's not cause and effect. That's just a statistical relationship between these two variables measured on a continuous or interval ratio scale. Now, the next question we want to know is that statistically significant? Could that happen by random chance alone? Or maybe there's something going on there and I might have a chance at rejecting my null hypothesis. All right, to figure that out, we're going to look at the SIG, which is an abbreviation for significance. It's two-tailed, and we're going to follow that across. So the SIG for this particular correlation is a 0.283, which means that the chance of this correlation, a negative 0.131, happening by random chance alone is 28.3% of the time, with 69 people in a sample. Now the question then becomes, do we accept or reject a null hypothesis? How do you figure that out? We look at the SIG number, we follow it across, it's a 0.283. If this number is less than 0.05, we're going to reject the null hypothesis. Let me say that again. If this number is less than 0.05, we'll reject the null hypothesis. If it's greater than or equal to 0.05, we're going to accept the null hypothesis. So you can see in this case, although there is a negative correlation, it is not statistically significant. In fact, that correlation could happen by random chance alone 28% of the time with 69 individuals. Why 69? Because that's how many people answered both the age variable and the GPA variable question. You have to have matched pairs in order to be able to calculate a correlation. In fact, you can see it's the exact same thing over here. It's just the intersection of this column with this row. All right, so we're going to accept the null hypothesis here. I want to show you one more feature where we can correlate more than one in the same analysis. I'll go back to correlate, bivariate. I've still got my old analysis in here. I'm going to add one more interval ratio scale variable from this data set. I'm going to add academic locus of control score, which I calculated as a composite variable. I'm going to add that one in. I'm going to click on OK. Now I have to scroll down and you can see I've got a new analysis, and look what happens. So we're still going to interpret the same way, the intersection of the row and column. In fact, here's a familiar negative 0.13 correlation. It's not significant. That number is not less than 0.05 with 69 pairs, so we answered it. However, if we look at current cumulative GPA and that academic locus of control scale score, you can see I've got a significant correlation. There's two ways to look at that. I can see that this number right here, the SIG, is less than 0.01, and in SPSS it gives me a little asterisk here, and it explains that this correlation is significant at the 0.05 level, two-tailed, and little footnote. And so this is also negative, so as one goes up, as current cumulative GPA goes up, their ALOC score goes down, or vice versa. As GPA is higher, this is lower, or as this is higher, that's lower. And so there's not a cause and effect relationship, but there is a statistically significant correlation. And that's it for me for correlations in SPSS.